Assalamu alaikum. We are starting the class, and we are doing some questions on electrostatics first. Now, as I had mentioned on the group that we have to slowly start the past paper, and then ideally we should be keeping a separate class for past paper. The diagram shows an uncharged ball coated with metallic paint. The ball is suspended from an insulating thread. It is placed near a positively charged rod. You can look at the question. You can look at the question. Okay, Asad, now it's time to discuss that we can, you people can contribute here because this is our first class on past paper. So I'm taking my time so you people can read the question, and we can discuss the answer, which diagram shows the charge distribution on the ball. The ball is covered with a metallic paint. Now the point is there. The point is there that if the rod is placed near to it, it will be an induction like this. I have shown the first step. This is called electrostatic. This is called electrostatic induction. Now read the question and let me know the true answer. You can answer on the mic or on the chat. D. Asad, you reply. D, right. It's only marking. Already I have shown the working. This is their favorite topic, rubbing. A polythene rod is rubbed with a cloth and the cloth becomes positively charged. When something is gaining positive charge, it means it's a case of loss of electron. Which statement describes the transfer of charge? Positive charges cannot transfer. Positive charges cannot transfer. In my notes, I had explained you that only the electrons are transferable. Only the electrons are transferable particles. So either it is A or B. I have made the diagram. Cloth is becoming positive. So cloth is losing electron and polythene rod is gaining electron. A positively charged rod is brought near to an isolated uncharged conducting sphere. Positive will definitely induce negative in front of it and positive on the other side. Plus and minus should be facing each other. And it's a conducting sphere, so electrons can transfer. I have made the concept. You have to select the answer for me. Right, these answer. A polythene rod becomes charged when rubbed with a dry woolen cloth. The charge causes as a result. Remember, friction transfer electrons. Only transfer of electron is the case. Electron is the only particle. Electron is the only particle which transfers during charging process. Magnetism has nothing to do with this concept. Okay. Asad is saying answer is A. Second student also, please. Maha, I think. Okay, good. One sphere is positive, and it's a case of induction. This is called induction. Okay, B is fine. Which row correctly names an electrical conductor and an insulator? This is now a memory type thing. Select a conductor and an insulator. B is the right answer. A metal sphere is connected to Earth. A positively charged rod approaches the sphere and stops before touching it. This is a very technical concept. When you give a touch, the same charges will transfer. If you give a touch, same charges will transfer. What is the movement of charge on the sphere and what is the final charge on the sphere? It's in closed feature. This is called induction. He has connected it with the earth. When you do the earthing, what will happen? The negative will not move because negative is being held by the negative charge is being attracted by the rod. But the positive charge will invite electrons and gradually this side will be neutralized. So positive will disappear. Positive charge on the sphere. Let me remove it so I can give a better idea. Now positive rod will disappear. Positive charge will disappear. Only negative is left. B. Why B? No, actually, the rod is present. He has not removed the rod, or has he? Let me. The rod is there. Until the rod is there, look, this is the rod. Until the rod is there, it will not allow the negative to run away. Until the rod is there, it will not allow the negative to run away to get earth. No, I said D can't be the answer. Remember this concept. In solid conductors, positive charge does not move. Electrons come from the earth and the remaining charge will be negative. A positively charged rod is held close to an earth metal sphere. A very similar question. When you bring the rod, look it carefully. This side will become negative and this side will become positive. positive part is connected with the earth. So it will invite electrons from the earth. Okay. After some time, the electrons coming from the earth will neutralize this part and only negative left over. Now, I have given you the story. You have to give me the answer. It can't be neutral because earthing is there, but the rod is also there. Look at the screen. After earthing, answer is A. Two charged metal spheres are suspended close to each other, which diagram shows the charge distribution on the sphere and the direction on the sphere. Like charges repel. Like charges repel, unlike charges attract. So you have to see which is the right option. Like charges repel. Repulsion means opposite arrows. B or C are the options, B or C. It is asking for repulsion. No, he's not asking for repulsion, I think so. He has not used the word repulsion. I know B is the right answer, but why not C? What's the wrong with C? The C, how it is possible that plus minus are away from each other? If I draw plus, if I draw minus, it should be like this. So C is also wrong. Now, do question number 10. It's a memory question. Glass, plastic, rubber. Okay, Asad says A. Okay, good. Now, we are back on our theory work. And as mentioned, you people have to arrange past paper books. MCQs we can do on the screen also, but you need a book for your own working. And I have shared with you the books. You have to buy the books, but buy the unsolved books. You can buy any unsolved book, but topical and unsolved. We were doing, as far as I remember, we were doing electromotive force, EMF. Please check your notes and let me know. Please check the last class work. We had a concept, we had given the definition. The concept was there that EMF, electromotive force is actually the concept of electromotive force. What is the concept of electromotive force? That electromotive force is the total voltage which a new cell can produce. It is the maximum voltage for a cell. This was the definition. This was the definition. Quickly revise it. Already we had written it, but quickly revise it. Electromotive force formula. We had also written it. Just quickly revise. It's a type of voltage. EMF is a type of voltage. I think we had written this formula also, but look it again. Now, we had discussed this concept also, that EMF and PD are dimensionally consistent. What is this dimensionally consistent meaning? It actually means that they have the same unit, they have the same unit volt, but they are physically different features. They are physically different quantities. Now, we are starting our concept here. We are starting our work here. Every power source has some resistance called as internal resistance. Now, this will be the first concept of this article for today. Just like you have a battery, when you charge the battery, battery heat up, which means there is a resistance inside the battery. The resistance inside a battery, the resistance inside a battery is called internal resistance. You have to copy this screen. You have to copy this. Let me know once you have copied it. Now, what is the concept of EMF? EMF is the maximum voltage. As I mentioned that what happens when you are running a new battery, every battery has two resistors, two resistances. One is the resistance of the battery itself. One is the resistance of the battery itself, and one is the resistance of the external circuit. So whenever you design a battery, whenever you design a battery, you always get two resistors. One is the resistance of the battery itself. One is the resistance of the battery itself, which is called internal resistance. Second is the second is the resistance outside the battery. For example, your mobile phone has a battery heat up, which shows there is a resistance inside the battery. This resistance is called internal resistance. Your mobile phone is running on the battery, and in physics it is called external resistance. Now, when you run a battery, some voltage is lost within the battery and some comes out. So this will be our next concept. For example, this is my battery and it is 9 volt. This 9 volt is called EMF, and I have a lamp attached with the battery. Now, when I run the lamp, suppose my lamp uses 8 volt and the battery itself wastes 1 volt. Now, this is how actually circuit works. This 1 volt is called internal voltage and 8 volt means external voltage. So in every circuit, some voltage is lost within the cell and some voltage is available across it. That is why batteries, generators, they waste energy. When a generator is running, it produces a lot of noise. That's a loss. That's internal energy. Now you have to copy this screen. I have to say Maghrib Namaz, and I'm just coming. If any one of you wants to say it, I couldn't say it yet. So I'm just coming in a few minutes. You have to copy this. Now look at this concept. There is a small v and there is a capital V. Small v is the internal PD and the capital V is the external PD, and their sum is their sum is called EMF. write under it that when a power source is driving a circuit, right under it, when a power source is driving a circuit, when a power source is driving a circuit, some of the voltage is lost, some of the voltage is lost within the power source. Some of the voltage is lost within the power source. Some of the voltage is lost within the power source, while the remaining voltage is available, while the remaining voltage is available for the external resistor, So what is the concept? When you run a cell or when you run a battery or you run a generator, when you run a power source, okay, remember this concept. When you run a power source, some of the voltage is lost within the source. A generator produces sound. When you charge a mobile phone battery, it always get heat up, which shows that it is wasting some energy. So course has a concept. Our course has a concept that EMF is the total voltage. Some voltage is lost within the battery and some is available to you. Now you have to copy this screen. Now, some voltage is lost some voltage is lost on connecting wires. You must have seen long wires in your house, especially the extension lead. They also waste voltage, but normally, but for short wires, this loss is ignored. You have to copy this screen. So if the wires are short, you can ignore this loss. But if examiner says long wires like extension leads, then you should consider it. Now you have to copy this concept. Sure. Let me show you the screen again. If the wires are short, you can ignore the loss. Resistance is proportional to length. Now, as mentioned earlier, resistance divides in external and internal part. Now, EMF is the sum of V plus V. EMF is the sum of V plus V. You have to copy this screen now. Now look at this concept that normally for short wires, we ignore the potential difference on the wire. And now we have a small derivation. E is equal to V plus V. According to Ohm's law, E is equal to IR plus IR. If I take I common, I can get this working. If I take this common, if I take it common, I can make this formula I bracket R plus R. You have to copy this. EMF versus PD. This is their favorite topic to discuss. Now you have to make a concept. When you are using a cell, it is converting electrical energy. When you are using a cell, it is converting, suppose, it is converting chemical energy into electrical energy. It is converting chemical energy into electrical energy. This is called the concept of EMF. Now, suppose you use the cell to run a lamp. You have the cell and you connect a lamp with the cell. Now what happens? Now electrical energy converts into light energy. So one is called EMF and one is called PD. What is EMF? When any form of energy converts into electrical, it is called PD. I'm sorry, it is called EMF. And when electrical converts into any other form, then it is called PD. So you have to give a side heading. You have to give a side heading for this. And then copy this definition. Now make this concept with PD. Make a concept when you are using electricity. When you are using electricity, then it is called PD. So you have to copy this screen now about PD. Let me know once you have copied it. Okay, so we give a contrast. We give a quick contrast. Look, any form of energy to electrical is EMF and electrical to any other form is PD. You have to copy this screen. So we keep it up to here. Let me know if you have copied it. Okay, so we keep it up to here and we will inshallah continue in our next class. Allah Hafiz.